All right, here's a quick overview of graphs of piecewise linear functions. So the first part of this is we should decide what makes up a graph. You're going to have two axes, an x-axis and a y-axis. So here we have our x-axis, which is the horizontal, and the y-axis, which is your vertical axis. Any graph is going to have a title. It's also going to have a independent, which is your x, independent variable, and with that we will have units. Sometimes instead of x it could be t, depending on the context of the problem, and the y variable could sometimes be considered h for height, again depending on the context, but this is going to be your dependent variable, which is going to be based, again, we're going to have units. With dependent, it depends on the independent variable, which is why it's the dependent one. So as we move through time or left to right, the height of many of these graphs will change. So this is your general structure. Obviously, you're going to have units here, often start 0, 1, 2, 3, etc. And then up the side, you might start 0, 1, 2, 3. It's important to realize that whatever scale you decide to use along the x-axis, you stay consistent. It's not appropriate to go 1 and then 2 and then 3. That would just be inappropriate. That's a different type of scale. And with all of these linear graphs, we want to have a scale that incrementally stays the same. So, looking at piecewise graphs. Piecewise graphs are graphs that are made up of several pieces. For example, we can look at a quick sketch of a graph. So again, we'll put in all our pieces and parts here. So we'll go 2, 4, 6, 8, 10, and we'll count up, let's go 5, 10, 15 or so, and then we will sketch in a graph here that will look, I don't know, something like this. The actual drawing of this graph is not important. So what makes this graph a piecewise graph is that it is made up of multiple lines here. And so we have time across the bottom, and this is going to be in minutes. And on the y-axis we have elevation in feet. And so as a title, we can just simply call this elevation versus time. So we have an elevation versus time graph. And so what this means is that as we go through time, so at time 0, we are on the ground. And then as we proceed through time, meaning as the clock turns, we are going to go up or down this elevation. In this case, we're talking about 5, 10 to 15 feet. So, for example, we could pretend that we are on a ladder, or let's just say we're on a hill. That might be the easiest way to think about it. But it doesn't have to have any horizontal travel. You'll notice it just has elevation and time. There is nowhere that there is any conversation of left to right movement. So when we look at this graph, from 0 to about 4, to this portion right there, from 0 to 4, we're going up. And we're going up at a steady pace, up to about 10 to 15 in that range. And so if we were to picture this, let's draw a quick little ladder. Okay. And we have a little ladder here, and we have a little man that we want to be climbing this ladder. So it takes him about 4 minutes to climb up to about this high. 4 minutes to get about that high. And then he takes about 2 minutes and just waits. So this portion right here does not imply horizontal movement. What this says is he's not going up or down. Could he be staying horizontal? Sure, he could move left and right. But in this case, if we're talking about a ladder, he's probably just sitting there and waiting. So as we look at this, it's for about 2 minutes he waits. For 2 minutes. And then he goes up another 5 feet or so. So up. And it takes him not very long at all. So why don't we just call it 30 seconds to go the rest of the distance there. And then from 6 to 8 or so, he waits again. So waits again for about 2 minutes. And then it looks like he slides all the way down the ladder almost. And so he goes down quite quickly, again about 30 seconds, and this is to go all the way from 15 to about 2 or so. And then I suppose he catches himself and then collapses to the floor in that last minute or so or takes a slow step down. So we can see that piecewise functions are for when we have disjointed movement. So it's not when you're walking steadily down the road, it's when things are changing. And so as different environments happen in and around what's going on. And so piecewise functions really are all about intervals. So the last piece of this that I think is important to talk about is this idea of interval. So again, if we just sketch in a quick graph here, and I'm not going to fill out all of it this time. I just want to put the axes in, and then if we just stick a graph here, and we have our graph, we can look at how there's 3 different intervals here. So we have this first interval from here to here. We have another interval here to there, and another interval from here to there. Now, this set of intervals is not really clear where this point and this point belong. Do they belong in the first interval, which goes 0 to, I don't know, 1, 2, 3, 4, 5, 6, 7, and 9. So is this interval here at 7, is that included? So are we going from 0 to 7 and including 7, or are we going from 0 to 7 and not including it? So notationally, if we included the 7, we would say 0 to 7, and we would use a square bracket to say that we're including it. Now, if that was the case, we wouldn't include the 7 in the second section, and maybe we include the 9 in the last one. Again, it's not really clear how that works. 9 to infinity, and infinity isn't a number, so we never include infinity. So what might be clearer is if we had a different type of piecewise function. So if we come in here and again draw this, and we draw one, this time it's not going to be unclear. It'll be very, very clear where these points belong. And then we'll go ahead and put another one here. Open circle this time. And then we'll close it in. And then we'll just do that. So here, if we were looking at these intervals, again, 0 to 3 here, oops. So from what looks like negative infinity up to and including 3. And we know that we're including 3 because we have a filled-in circle here. For the second interval, we have an open 3 that goes all the way to, again, an open circle at 9, meaning we're not including 9 in the second interval. The final interval, we would have a closed circle, which means we're going to have our squared bracket, 9 to positive infinity. And again, we never include infinity because infinity is an idea. It is not a number that you can include. So that gives you the big gist of the idea as far as piecewise functions, doing some practice, and writing out stories that go along with these, and being able to take a situation and come up with a piecewise graph are the goals that we're looking for as we finish this up. So thank you. Look forward to seeing more of you.